Okay, so hey everyone. Today we are going to discuss this question quests from Codeforces around 916 div 3. This is a very interesting question, so let's discuss about it. Uh, yeah. Monocarp is playing a computer game, right? Wait a sec. Hmm. Monocarp is playing a computer game. In order to level up his character, he can complete quests. There are n quests in the game, numbered from 1 to n. Monocarp can complete quests according to following rules. The first quest is always available for completion, and ith quest is available if all quests j less than I have been completed. That means if Monocarp completes let's say this quest, then he can complete this quest again and again, but he won't be able to do this again, right? Because he hasn't completed it once, right? Note that Monocarp can complete the same quest multiple times, right? So he can perform this quest multiple times, condition given that he has completed that quest at least a single time, right? So continuing, for first completion of ith quest he will get AI points, right? And after subsequent completion of ith quest he will get BI experience points. That essentially means if he completes this quest, let's say this quest for first time, he will get AI points. Okay, and then he moved here and he again wants to complete this quest, but this time he will get BI points. Let's say this is 1, this is 2, so he will get B2 points, right? So Monocarp is a very busy person. He has free time to complete no more than K quests. Okay. Your task is to calculate the maximum total experience Monocarp can get if he can complete no more than K quests. So I'll explain the question. This is the input format. Test cases, value of n and k, value of array A, values of array A, and values of array B in this condition. So I'll just explain the question in my words. So basically you have two integers n and k. N would be the number of quest, right? And k would be number of quests Monocarp can complete. Number of k distinct n distinct quest, you can say, right? Like, okay. So as input format we have this, and we would be given array A and B. So this is array A, let's say this is array A, and this is array B. This both of them would be of size n, because A would tell you the points scored at first time scoring available, right? And second time, B would tell you the second time, right? So what we have to do is maximize the score in k times. Like Monocarp can play max to max k times, right? So we can complete k quests. Oh, so what is the optimal approach here? Like, if you go brute force way, you can like see for, if you this AI with this, you can make like many pairs like this and compare. This would take you off n square, which is not feasible. So what is the ideal solution for this? What I'm saying is, let's just say Monocarp is right here, okay, on AI first quest, right? A1. So he can complete B1 next time, right? He would be able to complete B1. Let's say Monocarp just completes A1 and B1. So for k times, he would one time he would play with A1. His total points, let's say sum, is to A1 plus k k minus 1 into b1. See, he would play a1 one times and remaining k minus 1 times he would play b1, right? So now moving forward, if let's say monocarp goes here, so now he plays a1 and a2. He would play a1 and a2. So he could complete, he can again do b1 and b2, right? He can do any of b1 and b2 now because he has completed this I. So you can do any previous quest anytime, but you cannot do forward ones, right? You cannot do these ones or these ones except you are going one by one. So ideally what we should do, he has to maximize his score, right? He has to maximize his score. So what he will do is choose maximum of b1 and b2, maximum of b1 and b2, so that his scores maximize, right? He would choose maximum of b1 and b2 and add this in sum, right? He would do something like maximum of b1 comma b2 multiplied by how many turns he has left, right? He has played 2 turns because to get a1 and a2, so he has left k minus 2 turns, right? So to generalize, see carefully, let's generalize this. This is my observation, and this observation was basically because of this thing. Like, you know, once you can complete any of the b quests, like if your I index is here, you can complete any of these, then the optimal way should be you can choose the maximum element. Why would you choose the less element, right? You can choose the maximum element till this index. Let's say this index is here, till here choose the maximum element, do not choose this, and you can choose any maximum from this, right? That would be my intuition for this. Now moving forward to right, we were generalizing. Let's say we have this AI, we can choose any of this, then maximum of this basically. So I'll just generalize the formula. It would look something like this: summation till AI 1 to I plus k minus I times maximum of b1 b2 up to bi, right? Yeah, this would make sense if you observe the previous formula. I've just generalized it. Try it on pen and paper, you will realize. So moving forward, this sum would be the maximum sum for ith query, right? This is the maximum sum we can obtain if we are traversing just a of I and then we have some b of i's for it. But in answer we want maximum of all these sums, right? Maximum of all these sums. So what we are going to do is basically do this process, do this sum calculating process for all AIs, right? I think we should directly move into the code because the code would make it much clearer, but I'll try to explain it this way also, so you can try implementing the code by yourself. So basically what we will do here, like we are calculating this sum, right? We're calculating this sum, we are doing it for AI. This summation, this can be written as a1 plus a2 up to AI, right? So we are basically increasing where I is from 0. Let's not go there. 0, it's one based indexing. I'm explaining in one based indexing, but in code I'm doing 0 based indexing. I is going from 1 to n, right? So this would also change, and maximum of bi would also change. Now what we are doing actually is calculating sum from 1 to n, and we are calculating this different sums. We will have n n sums basically. And some might be same and some might be different. We are taking best of this is our answer. Right, we have n different sums and best of these would be our answer. Now how to calculate this? Like calculating this would take you of n time, and this would take n time again, so n square. So instead of calculating our a of I directly, we would use, yep, you guessed it right, prefix sum. Right, and for this also I have got some interesting thing which is related to prefix sum, like prefix array of maximum. I have used this, so I'll just explain what I've done. Create an array, let's say pf prefix sum of a. So what you would do in pf array, as we all know, this would store 0th element, this would store 0 plus 1, and this would store, like, this is first element, right? So p of 1, f of 1 plus a of 1, right? We would calculate the prefix sum like this. If you have any doubts regarding this, just watch some video for prefix sum. And yeah, so we have calculated the prefix sum, so we know the sum for ith index, right? We know what would be the sum for ith index, so we can get the sum in O of 1 now. So this issue would be resolved, cause we can get the sum in O of 1, right? Moving forward, what we are doing now is calculating, let's say I have array called mxb, which would calculating maximum element up to ith index, right? This is our mxb, and for ith index, right, I'll just write formula, you'll get the clarity. For mxb at ith index, we would have the element look like this: maximum of b1, b2, b3 up to bi. We would store maximum of bi up to ith index. For I plus 1, we would have maximum of basically mxb of I plus 1 should be equal to maximum of mxb of I comma b of I plus 1, right? We have just written this whole thing as this cause we know one very basic property, like maximum of a comma b comma c is equal to maximum of maximum a comma b comma c, right? We are just using this property. So what do we get from this now? We have calculated this thing, and we have calculated, wait a sec, we have calculated this prefix sum. This resolves our issue. Like, we had an issue in calculating this in O of n, right? And this also in O of n. So now we can calculate this in O of 1 and this in O of 1. So, and the whole sum loop, this would take O of n to get best sum. What we will do is, let's say, create an answer variable, answer equal to maximum of sum comma answer, and we will just print answer. This would be our solution. If you understand this, just try to code it by yourself. If you didn't, I'll just explain the code now. So this is my solution. I'll just copy paste it so it will be easier to explain. So I'm taking the input of test cases right here. Okay, What the heck? I'm taking the input of n and k, and the solve loop is basically loop of test cases. Taking the input of b and n, and this is taking input a and b. So now I have created an mxb array as discussed earlier, and initializing the first element of the mxb to first element of b, like the zeroth element of this to this, and then calculating as we have discussed above. You can just I'll just show you this thing, right? This is same as this. And now we are calculating the prefix sum similar way, the same old approach. Now we have from here is maximum element prefix and prefix sum of a, because we would choose every time maximum from b and prefix sum from a. You should observe this carefully, why this is working. So think about it, you would realize why this is working. Go repeat the previous part if you didn't understand why the whole thing was working, right? So we have one answer variable like this. If k is less than n, you can just skip this step. I'll just explain this why I'm doing this, but you can just skip this step and just do for I equal to 0 to I less than basically k comma n, minimum of k comma n, right? Basically instead of the if else conditions, you can just do for int I equal to 0 to I less than minimum of k comma n I plus plus. You will get the same result. So remember this, instead of doing the whole thing two times, don't be like me, just use this one optimally. Think about this, you would realize you would realize why this is working. So I'm calculating the sum as discussed in our formula. This is I minus this minus 1 is because of 0 based indexing, right? And the answer would store the maximum of answer comma sum. I'm doing the similar thing for else loop, like I'm calculating the sum the similar way. This is n minus 1 because we have taken already n terms, like basically like our k is greater than n. I'll just explain my logic, but I'll suggest you to do by this logic. This is much preferable, but I'll just explain. If k is greater than n, I'll just sum over all k, like okay, wait, this is the similar thing right here. So I'm calculating pf of I and n minus I minus 1 term like into mxp right here, like this is same as this, and afterwards I'm adding the sum plus k minus n into mxp. So think about this, how it is working. If you don't understand, just use this for loop, right? And again we are maximizing this like we are choosing the maximum of answer or sum and storing it in answer variable, and at last we are printing the answer variable. So that's it. Thank you for listening and see ya.